All right, let's dive right in. We're going to tackle one of the biggest buzzwords in tech today, Kubernetes. I mean, you've heard the name, right? It's everywhere. But what does it actually do? Let's break it down.
And that's a really good question, you know? It's actually the key to understanding why it's had such a massive impact. Because the answer isn't just, oh, it's a cool new tool. No. It's about solving a really huge, really messy modern-day problem.
So to really get why Kubernetes is such a game changer, you've got to understand the chaos it was born from. It's really an evolution story. And like a lot of tech stories, it all starts with a single server. Think about it like this. Way back when, we had physical servers. They were clunky, slow to set up, and super wasteful. Then came virtual machines, or VMs, which was a big step up. Things got faster, but it forced us into this frustrating game of resource Tetris, manually trying to cram as many apps as possible onto one machine to be efficient. And then came containers. Containers. They give us these perfect, neat little packages for our apps. But they created a whole new kind of chaos. How in the world do you manage hundreds or even thousands of these things at once? And this is where our hero enters the story. The world was crying out for something called a container orchestrator, basically a system smart enough to automate all that chaos for us. And the undisputed leader that emerged from that need? Yep, Kubernetes. And I love this quote because it just nails the core mission. See, it's not just about running containers. It's about running them reliably at a massive scale so the developers, can actually sleep at night. So how does it pull off this incredible reliability? Well, it's all about a massive shift in thinking. We're moving away from the old way, the imperative way, where you have to give step-by-step commands. Do this, then do that, then check this. Instead, with Kubernetes, you just declare what you want the end result to be. You say, this is what I want my system to look like. That's it. And Kubernetes works tirelessly to make your declaration a reality. It uses this constant, relentless process called a reconciliation loop. Think of it like a thermostat for your applications. It's always observing the current state, comparing it to the desired state you declared, and then acting to close any gap. Is a container down? Bam! It brings a new one up, automatically. Did you say you need 5 copies of your app running? It will fight to the death to make sure there are always 5. This loop, it's the real engine of Kubernetes. Okay, so that's the high-level philosophy, right? The why. But let's get practical. Let's get down to the nuts and bolts. How do you actually run your application container inside Kubernetes? What are the building blocks? Well, everything in the Kubernetes world starts with something called a pod. It's the smallest, most fundamental thing you can deploy. You can think of a pod as a little wrapper, a little home for one or more of your application containers. It gives them a shared space to live and run in. But, and this is a key secret, a pro tip that trips up a lot of beginners, even though the pod is the fundamental unit, you almost never create a pod directly by hand. Why not? Well, because we have much smarter, much more powerful tools to do it for us. Instead of messing with pods directly, you're going to use something called a deployment. This is where you make your declaration. You just tell the deployment, hey, I want 3 copies of my web server running, and the deployment takes over. It uses that same relentless reconciliation loop we talked about to make it happen and to keep it happening. And this is where the real magic happens. Let's say you want to update your application. You just change one line in your deployment configuration. That's it. The deployment sees that change and automatically starts spinning up new pods with your new version. Crucially, it waits until those new pods are perfectly healthy and ready to go, and only then does it safely shut down the old ones. And what's the result for your users? Nothing. 0 downtime. It's beautiful. All right, so your application is up and running in these pods managed by a deployment. That's awesome. But wait a minute. Pods are ephemeral. They can be created and destroyed at any moment. They come and go. So how does anything find them? How do your pods talk to each other? And maybe more importantly, how does the outside world talk to them? The answer is a brilliant little abstraction called a service. Think of it like a permanent, stable phone number for a group of pods. The individual pods behind that number might come and go, they might get new IP addresses, get replaced, whatever, but the service's phone number never changes.
It gives other parts of your application a single, reliable address to talk to.
So Istio, a service, is the go-to for handling traffic inside your cluster. But what about traffic from the outside world, from your actual users? For that, you need an ingress. An ingress acts like the smart traffic cop or front desk for your entire cluster. It looks at incoming requests from the internet and routes them to the correct internal service based on the rules you define.
Okay, let's tackle another super common, really important problem. Your application almost certainly needs different settings for different environments, right? Your development database URL is different from your production one, your API keys change. So how do you manage that without falling into the trap of building a whole new container image for every single environment? That would be a nightmare.
The solution, and this is a huge best practice, is to decouple your configuration from your code. Kubernetes gives you two great tools for this. For non-sensitive stuff, like configuration URLs or feature flags, you use a config map. For the really sensitive stuff, passwords, API tokens, all that jazz, you use a secret. The beauty of this is that the exact same application container can move from development to staging to production. The only thing that changes is which config map or secret you inject at runtime. It's clean, it's secure, and it's efficient.
All right, let's zoom out for a second. We've covered the core building blocks you need to run an app: pods, deployments, services. But the real reason Kubernetes has become so incredibly dominant, the reason it's everywhere, is because it's evolved way beyond just managing containers.
And here's the big idea, the crucial insight you need to take away. Kubernetes is no longer just a tool. It has become a platform for building other platforms. That powerful declarative API we've been talking about, it's not just for running your simple web app anymore. It's for, well, everything. This idea has just unleashed this massive, thriving ecosystem. Now, people are using that same declarative Kubernetes API to manage incredibly complex things. You can manage entire databases declaratively. You can automate all your security certificates with tools like Cert Manager. You can even provision your cloud infrastructure, your VMs, your networks, using tools like Crossplane. The Kubernetes way of thinking is literally expanding to control the entire stack.
And the magic that makes all this possible is a pattern called operators. What's an operator? Well, think of it as a custom-built robot that you teach how to run a specific piece of complex software. It's basically a custom controller that encodes all the expert human knowledge about running, say, a database, and turns it into software. The result is that you can manage these incredibly complex systems as if they were simple built-in Kubernetes resources.
So when you step back and look at the whole picture, the transformation is just profound. We've genuinely moved from a world of manual, error-prone, step-by-step server tinkering to a new world. A world where our entire infrastructure can be declared as code, completely automated, and reliably reproduced over and over again. And that is why this all matters so much. At the end of the day, what does this do? It automates away all the tedious, complex, and error-prone grunt work of managing infrastructure. And that frees up developers to stop worrying about servers and focus on what they actually want to do: build incredible applications and innovate. So, let's leave you with this final thought. Kubernetes isn't just another tool in the toolbox. It's becoming a universal API for your entire infrastructure, a common language for describing and running software. So the real question for you isn't if you're going to run into it, it's how are you going to use it to build whatever comes next.